By the end of today's video, you'll know how to do basic object detection using Python and a model called YOLOV8. So let's have a look. So here's what I have up and running already. You can see that I've imported an image here of some boats. And when I run the YOLOV8 over this image, you can see that it's picked out all of the different things inside the image. So we have 1, 2, 3, 4 boats, 5 boats, and a person over here too. Let's take a look at a different image. So let's run test 0 through this pipeline and have a look. This time it's a picture of 2 people and a bus. So let's scroll down and see what the model picked out for us this time. As you can see, it's picked out the bus in the background. It's picked out the person. It's actually picked out 4 people in it. And one more image. Let's take a look at test 1, run the entire pipeline. This time it is a woman sitting alone in a room with 2 chairs. Let's scroll down and see what the model picked out. It picked out the person, the chair, the dining table, and the other chair. So in today's video, I'm going to show you how you can set up YOLOV8 to do the same thing. To get started, we're going to set up an environment. So I'm going to run python-free mbenv.benv just to create a new virtual environment inside of the directory that I'm working in. Then next I'm going to go source.benv/bin/activate. And we can now see that our virtual environment is activated. And next, I'm just going to install the dependencies that we need to do this project. So I'm going to run pip install Ultralytics. Ultralytics is the library that we'll be using to install the YOLO model. And we'll also need to install Pillow to show and annotate our images. So let's get those installed. Great, that looks like everything's installed. So I'm going to hop back over to my Visual Studio Code instance, and I'm going to create a new directory. So I'm going to go for YOLOV8 object detection PO, and I'm going to create a new file inside of here, which is just going to be called YOLOV8 object detection, which is the Jupyter Notebook suffix. Before I get started, the first thing that I want to do is make sure that my Visual Studio Code is using the virtual environment that I've just set up. So I'm just going to click on select kernel, go select Python environments, and I'm going to click on this top one here, which is .venv/bin/python. Next, I'm going to create some code blocks with some comments in them to indicate exactly what we're going to be doing step by step. So the first step, we are going to import our image using Pillow. Next, we are going to be loading our model using YOLO. Next, we are going to be running our model on our image. And then finally, we're going to be visualizing our results by annotating our image. So first and foremost, I'm going to import our image using Pillow. And to do that, I'm just going to type from PIL import image. So I've imported my library, but I don't actually have a test image right now. So I'm going to head over to Unsplash. You can use any image you like, but I'm just using Unsplash because the images are really high quality and they are free for us to use too. So I'm actually going to take this image here just for us to test on, mainly because there's quite a few different things in this scene. We've got a dog, we've got a person, and we've got a car. And so I'm hoping that the model would pick up on finding all 3 of those things inside of this image. This is a photo taken by Ben Bouvier-Farrell. So I'm going to download his image. Shout out to Ben Bouvier-Farrell for that. And then next, I'm just going to pop that image into our project. Okay, so I've dragged that image into the same directory that we have our Jupyter Notebook stored into, but the file name is a little bit long at the moment. So I'm just going to rename it to test0.jpg. And next, I'm going to import that image. So I'm going to call it image to process, and then I'm going to run image.open, and then I'm going to point to the test0.jpg. And then I want to show that image just to make sure that this is the correct image that we are using. And I'm going to hit play. I'm going to install some bits and pieces first. And I can see that our image is there. No annotations on it yet, but we haven't run our model on it, so that's to be expected. Next up, we are going to import the YOLOV8 model so that we can run this image through the model and see exactly what kind of results we're going to get out of it. So to do that, we can just go from Ultralytics, import YOLO, all caps. And then we are going to declare our model equals YOLO, and then we need to define a checkpoint. If I head over to the Ultralytics GitHub page, which are the team responsible for YOLOV8, we can actually see all the different checkpoints that are available by scrolling down. So we can see that we have N, S, M, L, and X. These are ranked in order of size, so n being the smallest and x being the largest. I've chosen s because it's slightly larger than the smallest one and it seems to get really good results. The checkpoint that I'm going to define is going to be YOLOV8s.pt. Now, if I log out our model at the end and hit play, we can see that it's going to download the latest version of the YOLO8 model to our drive. We can see that YOLOV8s has now been downloaded successfully as a result of running this line of code. And finally, the entire model has been logged to console, so everything is working exactly as we expect. I think we're about ready to run our image through the model. Getting results out of this model is really straightforward. So we can just go results equals model, and then we can pass it that image that we created at the beginning. So I believe we defined it as image to process, and then we can log our results to the console and just have a look and see what kind of results we get. Okay, so it looks like it's found a person, a car, a dog, and a handbag, which is about right. I don't remember seeing a handbag in the image, but we'll have a look at that later. This is really helpful for us, but it would be even better if we could visualize those images and be able to see where the model thinks they are in the image as well. And so the next step is going to be setting up some annotations so that we can visualize where all of these different things are inside of the image. To visualize our results, we are going to use Pillow again. So I'm going to import from Pillow. This time I'm importing image draw and image font. I want our text to be pretty big, so I'm going to define our font right at the very beginning. I'm going to run image font, load default, and I'm going to provide a size of 12. By default, the text is pretty small and I want to be able to read it, so this makes it a little bit larger. Next, we're going to use image draw to annotate our image. However, we don't want to modify our original image. We want to leave that as is. So in order to do that, we're going to create a copy of it every single time we run this block. And the way that we're going to do that is going to call it image to process copy, image to process dot copy. And I'm just going to log image to process copy to the console. We should be able to see, there it is, the copy of the image that we want to reference. Okay, so next we want to draw some boxes onto our image to visualize what the model has found inside the image. So before we do that, I'm just going to remove this log, and I'm also going to clear the cell's output just to get it nice and clean. Next, I'm going to define a function. I'm going to call it visualize outputs, and I'm going to pass in two arguments, the image and boxes, which are going to be our results. First, I need to be able to draw onto my image, so I'm going to declare a variable called draw. I'm going to use that image draw library, call the draw function on it, pass in the pill image, and we are going to declare the color type as RGBA. Next, we want to iterate over every single box that we have and draw it out onto our image. So let's do that next. To do that, we're going to do a simple for loop. We're going to go for box in boxes. And now we need the coordinates of the box to know where to draw it. To do that, we can just go coordinates equals box.xyxy dot squeeze. Okay, so we just wrote quite a lot of bits and pieces out there. Let's go through that step by step. So first, we are getting the xy property from box. YOLO very helpfully provides coordinates in different formats based off of different libraries and ways that you may want to process this data. The way that you want your coordinates to be formatted might be different case by case. For image draw, which is the library that we're using to annotate our image, it expects them to be in the XY format. There's more details in the description about the different formats that you can get these in, but for now, the only one you need to worry about if you're using image draw to annotate is XY. Next, let's move on to squeeze. The XY value is a pytorch tensor. By default, it has an additional dimension that we don't need, so we're going to run squeeze to get rid of that dimension. And finally, the numpy function is responsible for turning our tensors into a numpy array so that we can use it with the image draw library. Next, let's draw a rectangle using those coordinates. So I'm going to go draw.rectangle. I'm going to pass in the coordinates that we just created. I'm going to specify the outline color to be red, and I'm going to specify the width to be 1. That should create a 1 pixel outline, which is going to be red. Finally, for now, I'm just going to return our pill image, the image that we've just been drawing on, and then we can finally run visualize outputs, pass in our image to process copy, and then we just need to pass our result from earlier's boxes. So to do that, we can go results 0.boxes. And now if I hit play, we can now see that we have boxes that are drawn around every single subject in the image. It's even caught this handbag that I did not spot the first time around. It's got the car, it's got the person, and it's got the dog. It's worked out perfectly. This is really cool, but it would be even better if we knew what the model thought each box was. So for example, we would want to see a tag for this one which says dog, person, car maybe. So in the next steps, we're going to do that. So attached to each one of these boxes is something called a class. That class is a numeric identifier. So let's see what each one of these boxes classes looks like. We can do that by just running inside of our for loop box.class, and we're going to print it, box.cls. I'm going to hit play, and we can see that it's logged 4 separate classes. Once we have the class ID for each of these boxes, there is a handy object that we can reference to be able to look up each one of these IDs and see the corresponding readable label for it. So for example, we might hope that 2 is car or 0 is person. To do that, we are going to have to do a little bit of work to this class value because right now it's in tensor form. We need it in a NumPy form, and it looks like it has an additional dimension that we don't need. So to do that, I'm going to create a new variable inside of our for loop. I'm going to call it class ID. I'm going to go box.cls.numpy, which, as we said earlier, is going to turn our tensor into a NumPy array. And now that we've converted that tensor to an array, we just need to grab the first value inside of that array, which in this instance is 2, in this instance is 0, 16, 26, for example. And that is how we do it. To verify, I'm just going to print our class ID, and then I'm going to run our code block once again. And we can see that we have 2, 0, 16, and 26, which is exactly what we were hoping for. Now that we have the numeric class ID, let's use that names object that I mentioned earlier on to be able to look it up and get a human readable representation as to what this box is. So to do that, I'm going to declare a new variable. I'm going to call it tag. I'm going to grab our result from earlier on. So the first result from our model's result earlier. And then I'm going to grab the property names. And then I'm going to subscript using that class ID that we just defined. Now, if I print this tag out, we should see human readable values. We can see car, person, dog, and handbag, which is exactly what we were hoping for. Now we just need to draw onto our image next to our rectangle. To do that, I'm going to start by getting rid of this unnecessary print command, and I'm going to define a text box by going draw.textVbox. And then we are going to pass it the X and the Y coordinates of our box. And to do that, we can just go coordinates and the first value and then the second value. Because we know from earlier on that this box's coordinates are X, Y, X, Y, which means the first and second value are going to be X and Y, which is exactly what we want. The next value we need to pass into this function is the words that we want to display, and that is going to be our tag from earlier. So that's our human readable class ID. And then finally, we want to pass it that font that we created earlier on. And so to do that, we just go font equals font. So this will draw the bounding box for our text, but it won't actually display any text data. To do that, we are going to have to create a rectangle and then some text over the top of it. Next, we're going to draw another rectangle. We're going to go draw.rectangle, and this time we're going to pass it in that text box that we just created up here. Because we always want our text to be visible on top of the image, we are going to fill it in with a color. So let's fill it in with black. Now that we've drawn our rectangle, we just need to draw our text on top of it. So to do that, we are going to go draw.text, going to pass in our coordinates, our X and our Y coordinates one more time. We're going to pass the text that we want to display, which is going to be our tag, and we are going to pass it our font one last time. And now if I hit play, we can see that we have the word dog, handbag, person, and car. And those are all white labels with black backgrounds. The text is still a little bit small for me, if I'm honest, so I'm just going to scroll up and I change the size of the font to 18. Hit play one last time, and that's a lot more visible. So we can now see that the model did an excellent job of figuring out exactly what is in that image, and we have annotated and labeled our image exactly as we would want to. In the next video, we're going to be learning how you can fine-tune this model with your own data set of images so that it can get very, very good at performing very specific object detection tasks. Thank you so much for watching. If you like this content, please do subscribe. It's the best way of telling me that you're enthusiastic and excited about more of this kind of content, and it encourages me to keep on making it for you. Thanks again, and I'll see you in the next one.